Hello, everyone. I'm Kaslin Fields, and I'm a cloud advocate at Oracle. Yes, that's right. Oracle has a cloud. You can learn more about it here. If you're just walking by, if you'd like to join us, I'm going to be giving my lightning talk on how containers are like cookies that I gave yesterday. I'm also going to be going over the new comic that I posted last night. First off, I've been the container person wherever I've worked for the last 4 or 5 years, which means I get a lot of questions about containers. Mainly, what are they? And how are they like VMs? And a lot of these questions come from field sales. And when you're in field sales, trying to go to a customer and talk to them about containers, you don't have a whole lot of space to keep stuff in your head. So it's best to make things as easy to understand and easy to remember as possible. So I came up with this analogy that I think is really useful for understanding how containers work. So instead of talking about this diagram, which is commonly used to describe how containers are like VMs, today we're going to talk about this diagram. So first off, I want to talk about the bowl that the cookies are in, rather than the cookies themselves. So the bowl is like your physical infrastructure. Whether you're running containers or virtual machines, you're technically running them on some form of physical hardware. And that physical hardware has a certain amount of memory, a certain amount of CPU. Basically, it has a limited capacity that can be used for running containers and virtual machines. So you can run containers, you can run virtual machines, you can run both, but you can only run so many. So your physical infrastructure is like the bowl. Now for the cookies themselves. For this analogy, I'm referring to both virtual machines and containers as cookies. But virtual machines are like big cookies, and containers are like little cookies. So virtual machines are like big cookies because as a virtual machine, you're basically pretending that you have a whole machine. So you have to have your own operating system on that machine. And operating systems take up a lot of space. So your virtual machine is like a big cookie taking up a lot of space in your bowl. Whereas a container is smaller. It doesn't need an operating system because it's not trying to be its own machine. It's making use of the underlying operating system to do those things. So it takes up less space in the bowl. We can also take this analogy further. So whether you're running containers or virtual machines, your goal is to run some form of application. The problem is that application can't just run by itself. It has dependencies, binaries and libraries that it needs to be able to run. So your application that you actually want to run is like the chocolate chips. They are the best part of the cookie, and that is not up for debate. But the rest of the cookie, all of the flour, the sugar, the butter, that's like all of the dependencies that you need to keep with that app. Now you could just run your application and all of its dependencies on a machine. So imagine putting chocolate chips and butter and flour and sugar in a bowl. Now imagine you need to move that to a different bowl. You're going to have a mess. So you don't want to do that. So that's why we bake it up into cookies. Whether you use VMs or containers, you make your applications more portable. But like I said, the virtual machines take up more space. Containers are smaller. Containers, small cookies, also have a shorter bake time. Containers spin up much faster than virtual machines. Usually, virtual machines take a few minutes to spin up, and containers take a matter of seconds. So, shorter bake time, longer bake time, and difference in space. So, imagine that you're a system administrator. Your job is to take care of a development team, and that development team has application needs. So you have to make sure that those applications are running on some hardware somewhere and make sure that the developers have access to it. So basically, your development teams are chocoholics. They need their chocolate fix, but they don't really care how they get it. So you, as the system administrator, have a choice. You probably want to use cookies because at some point you're going to have hardware upgrades, hardware failures. You're going to have to move those applications for some reason. So you want to keep the dependencies packaged up with them and make it easy to move. But do you want to use virtual machines or do you want to use containers? I submit that you would want to use containers because they take up less space and because they spin up faster. And since they use the space more efficiently, hopefully you can satisfy your development team's needs without needing to request budget for another bowl. So that's my analogy about cookies and containers. If there are any questions about that, I'll take those. And then I'm going to move on to my new comic, which is about C groups and namespaces. Questions? Okay. I'm going to move on to the other comic. So I don't have slides for my other comic yet, so I'm just going to pull it up on my website. So this is my website, Kaslin.rocks. It's where I keep all of my fun little comics. So I'm using a different analogy this time to talk about containers from a system engineer's perspective. And I'm going to be talking about C groups and namespaces in Linux, if you're familiar with those concepts. If you're not, don't worry about it. I'll go over it. Today, we're going to talk about containers from a system engineer's perspective. So these are a few of the apps that we're going to be talking about in this analogy. As you can see, they are precious, pampered pooches. The problem with precious, pampered pooches is that they're a bit spoiled. So imagine having an application that has a whole machine to itself. All of the people are at its beck and call. It has all of the toys and resources it could want. It's spoiled. Like that. But operating systems are designed to help you be able to run multiple applications on the same machine, which is very efficient. That's more like a doggy daycare, where you've got a whole bunch of applications all living in the same space, all being taken care of by the operating system. The building that the doggy daycare is in is like the infrastructure, whereas the care that the dogs are receiving is like the operating system. One of the lovely doggy daycare assistants. But the problem here is that dogs don't always get along, and neither do apps. Dogs will fight over food, they'll fight over toys, and sometimes they just don't get along. So, the same thing is true for applications. They'll fight over memory, they'll fight over CPU, and sometimes they just can't coexist in the same space together. So how would we solve this problem? Virtual machines take kind of a straightforward approach to this, in that they pretend that there's a whole other machine there. So they have a whole different operating system, for example. Like we talked about earlier, you can run different operating systems on one physical machine by doing this, whereas usually you would not have multiple operating systems on one machine. So in terms of dogs, this would be kind of like making a whole row of townhouses where each dog gets their own house, which is a bit much for dogs. You probably don't want to build townhouses just for each dog. I mean, you might if you're like this guy, but hopefully you're not. So we would prefer to use the doggy daycare, but how can we do that without the dogs fighting with each other? So one thing we could do is make sure that each dog gets its own resources, its own toys, its own food. In computer terms, this would be like setting limits to make sure that your application can only use so much of the memory, so much of the CPU, so that they're not fighting each other over resources. And you can do this using C groups in Linux. And this is one of the core functionalities of containers. And this is how it's implemented, by using C groups in Linux. However, this is not enough to make sure that our dogs are going to get along. Sometimes the dogs just won't get along in the same space. And when that happens, all that's left to do is separate them. You could put several dogs together, or you could have one by itself. In Linux, you do this with namespaces. And namespaces allow you to group apps together and put them in their own isolated environment. So by using namespaces and C groups together, we create containers. So when you hear people say containers don't really exist, what they mean is this. There's no actual object or thing that is a container. It's just pieces of the Linux operating system that you're using together to create this way of running applications that is isolated and efficient. So it doesn't work for every use case, You might really love that app and really want to put it in a virtual machine or a bare metal machine where it has everything to itself. But in a lot of cases, containers will do just fine. So that's my analogy for the doggy daycare and C groups and namespaces, and my analogy for cookies and the main benefits of containers. If you have any questions, let me know. Thanks for coming.